Let's talk about ecological tolerance. So the idea of ecological tolerance is that if you consider what abiotic factors a given organism can thrive in, there are certain limits. Okay, so for instance, if I put you in a room that had very low oxygen, you wouldn't do particularly well. If I put you in a room that had too much oxygen, again, you wouldn't do too well. There's a certain range of tolerance that most organisms have for given abiotic factors such as oxygen, dissolved oxygen, salinity, temperature, humidity, and so on. So, for example, take this cute little salamander here. It's going to do great if there's lots of humidity, but if it starts to get dry, it's going to get stressed out. It's not going to survive. So, what we find is for any given species, we can delineate a certain range of tolerance levels for a particular given abiotic factor, and we call this spectrum its ecological tolerance. So just to make it pretty clear, so take a polar bear and a sun bear from Borneo. They're similar, right? They're ursids, but the polar bear has a set of adaptations that makes it able to thrive in very cold conditions, but not in very hot conditions. So if you were to take this polar bear, drop it off in Borneo, it's outside of its tolerance range, and it's going to die. Similarly, if you took the Bornean sun bear to the Arctic region, again, it's beyond its tolerance zone and it's not going to live. So they are both able to have a certain spectrum of temperatures in which they can thrive. But for each of them, there is a too hot and a too cold, and it's not the same for both of them. And so this range that we can delineate for a given species to thrive in for a given abiotic factor is called its ecological tolerance. Now, there are some species for which it changes over the course of lifetime. So for fish species, a lot of times salinity is one. We have freshwater species which can only survive in low salinity environments, and we have saltwater species that cannot survive in low salinity environments and can only survive in high salinity environments. And there's some things like, say, eels and salmon that are known as anadromous in the case of salmon, which means they lay their eggs in freshwater, or catadromous in the case of eels, which live in freshwater and lay their eggs in saltwater. In both cases, the juveniles and the adults have very different ecological tolerance ranges, and the species have to migrate during their lifetime to accommodate that change in ecological tolerance. I really like this graphic. You can find it all over the internet in different forms, but it really gets the idea across. So the environmental gradient, it could be whatever I want it to be. It could be temperature, humidity, dissolved oxygen, whatever we want it to be. What we typically find is for a species, if you expose it to a wide variety of that particular abiotic factor, from very low to very high, you're going to find that there's a bell-shaped curve, that the populations thrive at a certain level and they begin to diminish as it gets too high or too low. And so we find is there's a region which we call the optimal range for the species, which is where you're going to find most of them on the planet. On either side of that, if that particular abiotic factor gets too high or too low, let's just say for these butterflies, it's humidity. Okay, if the humidity gets too high, they begin to experience some stress, and only a few of them are able to live there. If the humidity gets too low, only a few of them can survive there. So we have a zone of what we call physiological stress, where there's fewer of the species. And then we have a zone of intolerance. There's just too little humidity. They can't live in this desert. There's too high humidity. They just can't live in this sauna, okay? So basically, for any species, we're going to find this bell-shaped curve. It's not always, sometimes there's a little bit of lopsided bell curve, but basically, this tolerance range is going to show up as a bell curve. And basically, in the middle of it is what we call our optimal range. So just here's another graphic showing the things, same thing. So here's one that's like hand drawn, but this still shows you the same idea that you have a bell-shaped curve. It may be lopsided, as it is in this case here. In the highest area where the peak is, where the mode is, you're going to find the most individuals. On either side of that, as it begins to drop off, you have a zone of physiological stress. And then you have a zone of intolerance on either side of that where you're not going to find them at all. And again, this x-axis is whatever abiotic factor we want to consider. Let's take the example of fish. Okay, an estuary is a region where we have changing salinity. So after a big rainstorm, fresh water comes in, the salinity goes down. After the tide comes in, the salinity goes up. So the species that live in an estuary have to have a very broad salinity tolerance. Whereas saltwater species, ones that live in the open ocean, it doesn't really change its salinity very much. So we find is they have a range of salinity tolerance. However, it's much more narrow. Now there may be some overlap between the two. That's why you might find oceanic fish in an estuary. Uh, but the tolerance limit for the ocean fish is much smaller. And if you've ever had an aquarium, you might have noticed this, that it's pretty difficult to manage a saltwater aquarium because those fish tend to have very narrow tolerance ranges for various abiotic factors, dissolved oxygen, temperature, salinity, because they are adapted to an environment where there isn't much change in these factors. The ocean is pretty stable ordinarily, whereas freshwater fish, there's often a lot of fluctuation. So they're more tolerant of these changes. And so it's easier for amateur aquarium people like my wife and I to keep freshwater fish because they have broader tolerance ranges. Now, back to this, we're going to talk about generalist and specialist species a lot all throughout the year. So, a specialist species tend to have very narrow ranges compared to a generalist species. So they tend to be less tolerant of change. We keep saying that. So specialist species tend to not do well with changes in particular abiotic factors to which they're adapted, whereas generalist species have more ability to adapt to these changes. They have a broader range of tolerance, so they're less likely to be stressed out and become extinct if conditions, the particular abiotic factor drifts one way or the other. Here's a graphic that's a good one for showing the difference here. So we have a black stripe top minnow. It has a pretty broad tolerance. In this case, this environmental condition happens to be dissolved oxygen. It can live anywhere from a high oxygen babbling brook to a very low oxygen stagnant pond, okay, or puddle, okay. Whereas the blacktail shiner, it doesn't have that same tolerance. It's more of a specialist. It can only live where we have very high oxygen levels in a running stream. If you try to put this in any other environment, it tends to experience physiological stress and die. All right, so that's pretty much it for ecological tolerance. Thanks for watching.